So, part 2 in the vector operators is the infamous cross product, which is a little bit, or I'd rather say much more elaborate and cumbersome than the dot product, and you'll find out why. But what I'm going to do, I'm going to switch and start by showing you why we need it in physics. Unlike what I did with the dot product I showed you at the end, I am going to start right out the gate with why we need the cross product in physics, and not of course only physics. Now, I want you to guys imagine that you have a rod that has a hinge right here, so we can rotate this rod about the hinge. This rod has some length r, and what we do to this rod is we apply a force, as you see right here. We apply a force and we start rotating the rod about the center, its axis of rotation about the hinge. So what is this? Before that we had the force pushing the box to the left or to the right. Now we have a slightly different scenario. So we expect the rod to start turning, so we need to define whether this rod is going to be turning clockwise or counterclockwise. So again, if you think about it, if you say that, well, this is, I call this a vector from here to there. Force is also a vector, so, well, this is my middle finger. The index finger points in the direction of the rod. Now, there is another vector that should be pointing out towards me, away from you, right? It's going to be pointing towards me. That's the sign of the circle, dotted circle, that we are going to call the torque. So essentially, we are we're making this rod spin, and the vector that is returned to us, the vector that is telling us that this rod is spinning towards this direction. So again, the torque points out in the third dimension, whereas the rod turns along this direction. So you can use the right hand rule, or just point out your fingers curling towards the direction of the rotation, and your index finger will be pointing towards what we now call torque. And of course, you will become, if you're not already familiar with what it means,